When we built the stencil at the beginning of this module, we chose to model it from the main table and from another table for the text block and the button. But right there, we said that we could also have chosen the flex control instead of the table control as the container. What's more, I'm going to save our stencil with another name. We had said that we could convert at any time a common table like this into flex, and vice versa. When we convert it, we see that the rows and columns disappear, and these properties appear inside the layout behavior group. The first one that catches our attention is flex direction, whose default value is row, and that'll determine that the two elements contained by the flex are arranged horizontally along a single row without columns. It'll be a little clearer in Figma. This symbol appears for the information frame, and this other symbol for the frame containing the title and the button. These symbols tell us much more than it might seem. The first one indicates that the elements of the frame, this and this, will be placed along a row, in other words, horizontally. First one, then the other. And also that these elements can have different heights, but that they'll be aligned in the center. Actually, they have different heights. If we look at this one, it has this height, and if we look at this one, it has this other height, which is the height of the container. But they're both vertically aligned with respect to the center. If we look at this other one, it's also a container with two elements. This time, arranged around the column direction. First one, the text, and then the other, the button. And they're also center aligned with respect to the edges of the other direction. Just as these two, whose direction is row, are centered with respect to the vertical direction. Chechu achieves this by saying that the container has what in Figma is known as auto layout. For us, that's called flex. Basically, it means that the contained elements are going to be placed along one direction, either horizontally, like this one, or vertically, like this other one. This GeneXus wiki page explains the control, and at the end, there's a link to this other page that gives an example. I'll use this page to see it graphically and make it clearer. It says here that these containers allow you to create flexible layouts, which allow you to place items, align them, and distribute the space between them in a container, of course. Even, or especially I would say, when their size is unknown beforehand or is dynamic. A series of properties are then displayed to configure the direction and layout of the controls. This would be the case of one container in row direction, this one in reverse, this one in column direction, and this one in column reverse. In the example, each container has 3 items. In this other example, we decide whether to allow wrapping if the size of the items, that is to say, their width, added together, exceeds the limit of the container. So in this case, we're allowing the wrap, that is, to extend in a line below, given that the direction is row, of course. If the direction were a column, it would extend into a second column. This other property indicates how we want the content to be justified. For example, if we want the items to be centered with respect to the direction, which in this case is row. This would be precisely the case of our information flex. So we come here and we're going to do flex direction row. For flex wrap, we're going to leave no wrap at first. And center justification, we see the options. We'll set the alignment of the items with respect to the top and bottom to be centered as well. And here it'll be clear what we're saying with that. On the other hand, if we allow the wrap, then with this property, we determine how to adjust the content with respect to the excess space. Well, I didn't intend to tell you all the possibilities of the control, but simply to introduce it, because this control is widely used both on the web and in native applications, precisely because of its flexibility. In this case, for example, this control would be more useful than the table control if we wanted that when the screen width decreases, if the two elements don't fit that width, to have them displayed in two rows, in other words, with wrap. The table doesn't allow this. It's much more structured. It has rows and columns, and in fixed quantities. Here we only have a row, if the direction is row, like this one, without columns. That is to say, where the elements are placed one next to the other according to the available space. And if they run out of space, if the wrap property is turned on, then a second row is created, and so on until completing all the items. When a control is inside a flex container, it takes properties, these here, precisely because of that situation. Of course, as with any other control, we can define design properties for the flex control, all those that we saw statically, or the more well-known ones of margin, padding, and so on through classes. For example, going back to Figma, when Chechu defined this container with auto layout, she set this horizontal direction, and paddings appeared to define the four edges, top, right, bottom, left. And it was also possible to define the gap, which is the horizontal separation between the elements, which she had set to 80 pixels. Look at the CSS code that appears when we ask for this. Doesn't all this sound familiar? Display flex, flex direction row, justify content center, align item center. We statically set these properties at the level of our flex control, and these two, padding and gap, we could place them in a class that will associate later to our flex control. Or we could also place them all within that class, because all that we can define at the level of the control can also be defined at the level of the class properties. Well, in the same way, we see that this other container also has auto layout, but in the other direction, in the column direction. Here we see the padding and gap properties. And again, if we copy the CSS properties, here's the display, the direction, column this time, align items, and the properties padding and gap. So we could also define this table as flex and set, of course, the column direction so that it's displayed in this way. From Figma CSS, we also extracted this, that align items is centered, which represents these items in relation to the edges of the other direction. And here we would have to select center. Well, they're disappearing. This should not be happening. I'm going to leave the default. We'll see it later. The content justification does have to do with the same direction of the flex, doesn't it? In this case, it's column. So we would also have to say centered for our case, even if the CSS didn't indicate it. Since it doesn't have wrapping, we didn't set it to have wrap, then this property comes into play and controls whether the size of the container is going to be adjusted according to the size of the children. Well, we would have to work with these aspects in order to place our elements in the correct way according to Chechu's design. At first, it may seem simpler to use the flex containers because we can copy Chechu's design criteria directly. With auto layout, we can transfer it almost automatically to GeneXus. But we have to be careful because this is a bit trickier. Note all the properties that are appearing now within this group. In this case, more appear because there are also those related to the participation of this internal flex within this other flex. As I'd shown you before, all these properties appeared here, such as size, width, and height, which had to do with this control's role within the parent flex. Well, because of these somewhat trickier issues, I decided to start teaching you with table and not with flex. Flex may seem a bit more challenging because of those properties that have to be better understood. Sometimes it gets confusing if I'm talking about content justification. What is its direction? If I have the alignment of the item, then one starts to get confused. But when we get the hang of it, it's actually quite simple. And, well, it actually has to be used carefully. When to use flex? When I'm implementing a design where the elements that will be, for example, along a row, if that's the direction, are not so structurally fixed in columns, and certainly, of course, when we want the wrap functionality. In this case, we didn't need it at first, because, as we said, when the screen width doesn't fit both elements, another different design will be made, which we haven't seen yet, because I asked Chechu to design them in another file, so as not to get confused now. Okay, I'll stop here as it's been introduced, which is what I wanted, and later on we'll see if we need to use a flex container instead of a table. By later on, I mean when we continue developing the screens of our application. A grid can also be flex. I mentioned this now, and I'll mention it again when we implement one of the grids in the future. I'll end this video now because I want to move on to the next module, but you can, if you want, try what I didn't try. For example, assign classes to the flex with the corresponding properties, and pay attention to the sizes given to the controls. Explore a little, and try to make the application with the stencil with flex look the same as it did in the other way, as we had it done.
De la otra manera, como la teníamos hecha.
That's the challenge I leave
ese es
for
el
you.
desafío que les dejo a ustedes. Nos vemos
See you in the next module.